Hi, in this video I'm going to show a model we built for a customer using envelope. This represents part of a manufacturing process. We're looking at a cross-section of the pressing process where tungsten wires, shown in black here, this is a 2 mil diameter tungsten wire, are pressed into a polymer matrix. The polymer is in red. And there can be different polymers. In this particular model, the only effects we've turned on are coefficient of thermal expansion and Young's modulus for the materials. We can show a certain amount of plastic flow as well. We were able to explain some of the customer's experimental results without even going that far. And I'll just show that part. So the process starts pressing at 130 C, a bit over the glass transition temperature of the polymer. And if you watch the material compared to the gray grid dots, you can see that we get some compression, very low Young's modulus, bulk modulus. So we press at 130 C, let it reach equilibrium there. Next step is we cool from 130 C to room temperature. So this is the end of the wire pressing process. We're trying to model everything below the glass transition temperature. Let's see what's going on. In the ideal case, above the glass transition temperature, flow should relieve strains if you go slowly enough. And strains are what we're concerned about here because the wire popped out, something pushed it out. Finally, when we get to 20 C, we release. We remove that green arrow, which was the force downward on the plate, about 1 atmosphere of pressure. And the wire does pop up. When we put in material parameters for polymer that did show this pop-up, we get pop-up in the model, and so far the converse is true too. When we put in the material parameters for polymers that did not show pop-up, the wire does not pop up. So far so good, and the next step is to put enough flow in here that we can see whether in some cases the process went faster through the glass transition temperature. Could we have frozen in some mechanical strains in addition to the thermal expansion? The system works by just putting a few equations representing the parameters for the material into these little elements, and then you draw a picture using the elements. I highlighted one in yellow. So you have simple equations that you can validate, but then you don't really have to peek inside those boxes again. You just drag them and drop them and connect them, and model your system more intuitively. Other people can understand it a lot better than a page of equations too. And it's a lot quicker to set up than a tool like ANSYS. Alright, thank you for watching.